Hello and welcome to my presentation. I'm Yuanmo, a PhD student in the Department of Methodology at the London School of Economic and Political Science. Here I'm presenting a working paper with my PhD supervisor Milena on estimating individual socioeconomic status of Twitter users. Let's start with the background. Socioeconomic status is a concept that describes people's social and economic position relative to others. It is one of the most fundamental concepts in social science, underlining major areas of research such as health, education, psychology, sociology, and public policy. The common indicators of SES include income, education, and occupation. SES is related to many other important life outcomes and thus essential to inequality and social mobility research. However, individual socioeconomic status indicators are rarely available for digital trace data, which limits the full potential for computational social science. Even if you are not directly dealing with socioeconomic inequality, you might want to use it as a control variable, but that's currently not available. Even for the most researched digital platform, Twitter, there is not yet an established method to estimate SES. Review in the field shows there are inadequate number of studies, and most of which have methodological limitations. The common approach in the field is to use supervised learning models trained with labeled SES and tweets. But here are two problems of the common approach. The first comes from the labeled SES, which could result in a potentially biased training sample. The other issue is the approach tends to use too much information. For example, all the tweets. As a result, once you get the SES, future use of the SES is limited. Therefore, to address the gaps and the limitations, we are proposing to estimate Twitter users' SES based on the brands they follow. Here, I'm going to illustrate the theoretical support and the rationale behind our method. The common indicators of SES, income, education, and occupation, are observational variables used to measure this latent SES. But if you look closely to the concept of SES, especially drawing from Bourdieu, who define SES as the function of economic, cultural, and social capital, you can see actually the common indicators are measuring one or the combination of economic and cultural capital. Therefore, in absence of the common indicators, what we can do is try to find other indicators of the economic and cultural capital, which brings us to another important notion from Bourdieu, which is habitus. Habitus means that people's socioeconomic status determines how they perceive and act in the world, especially one's economic and cultural capital will shape one's cultural interest and consumer preference. Veblen's conspicuous consumption also suggests this pathway. Then we believe actually on Twitter, users manifest their economic and cultural interest in the accounts they follow on Twitter. Therefore, the brands the user follow on Twitter could be a good measure of socioeconomic status. For example, following consumer brands, such as supermarkets, retailers, and chain restaurants, because they have a price tag and the associated lifestyle, it could represent a combination of economic and cultural preference. Following media and entertainment brands, such as news, sports associations, and TV shows, because they are minimal cost, it could be mainly represents cultural interest. Even if we don't know which brand represents higher economic and cultural capital, we can cluster users who tend to follow similar brands and project them on a line, which will serve as our SES scale. You can also think of this pathway in terms of homophily, where users in similar socioeconomic status tend to follow similar brands. Actually, using cultural interest to measure individual characteristics is nothing new. Bourdieu himself used multiple correspondence analysis to measure SES. Researchers in my personality study used Facebook likes to estimate a range of individual traits. Political scientists has also been using Facebook page likes and the followers of political actors' Twitter accounts with correspondence analysis to infer users' position on the left-right ideological spectrum. Of course, what's more relevant to us is Bourdieu's use of multiple correspondence analysis and the political scientists' use of correspondence analysis. As a simple reminder of what correspondence analysis is, it is a multivariate method to summarize the association between rows and columns of the two-way contingency table as the position between points in a low-dimensional space. For example, we have the bipartite network of brands and users represented with the two-way contingency table, and the correspondence analysis can summarize it in a lower dimensional space, for example, in a two-dimensional graph. Similar to principal component analysis, correspondence analysis identifies a low-dimensional space so that the variance of the original matrix is explained by the dimensions in descending order. For example, in our case, because we are assuming the primary reason of the user follow a brand is due to their socioeconomic status, so the coordinates in dimension 1, which explain the most variance of the original matrix, can be used as our indicator of socioeconomic status. Bear that in mind, we identified brands from 6 domains and had a set of filters to select active users in the US, which resulted in nearly 3.5 million users and 342 brands. We also used two-stage to reduce the noise and improve validity. Basically, at the first stage, we use a more restricted sample to identify the low-dimensional space, and then at the second stage, we project the rest of the brands and the users onto the low-dimensional space. We use the different source of data for validation. To validate the estimation for the brands, we get the audience educational level composition of the brands from Facebook Marketing API. Basically, we got a percentage of audience who graduate from high school, university, or master's degree or higher for each brand. For the users, we first extracted job titles from their profile description and then matched the job titles to occupational social class and the mean annual salary. With the job titles, we can do an aggregated level validation, basically exploring the association between the mean estimated SES for each job titles and the class and the salary. Of course, we can also assign the mean annual salary to individual users based on their job titles. That contributes to one source of our individual level validation. Another source of data comes from a very small sample, around 200 users, linked with survey data containing educational level and income. Thanks to Andy Guest and his colleagues sharing with us some data from their research. So let's have a look at the results. Overall, brands with higher estimated SES indeed tends to have an audience that have higher educational level. As you can see, brands with higher estimated SES is strongly associated with lower percentage of high school graduates audience, a slightly higher percentage of university graduates, and significantly higher master's degrees or higher graduates. In all of our analysis, we use the Spearman's rank association because currently we care more about the order instead of the scale. For the users at the aggregated level, this graph shows the users aggregated by job titles, the association between mean estimated SES and the mean annual salary, colored by class, where 1 represents the highest class. As you can see, the association is very strong, and there is a nice trend from bottom left to top right, whereas the median estimated SES get higher, the mean annual salary also gets higher, and the class also gets higher. Brands in similar class also tends to cluster, which is another good trend. The individual result is not as strong. Assigning the salary to individual users based on their job title, we got a correlation between income and the estimated SES. of 0.369. For the small sample linked to survey data, we got association between education and SES of 0.289 and the association between income and the estimated SES of 0.209. It makes sense that the estimated SES has a stronger association with education than income because we are capturing more of the cultural aspect than the economic aspect. As a reference, the correlation between income and education in the sample is 0.455, which kind of could be interpreted at the highest we can get. So to conclude, we propose an unsupervised method to estimate Twitter users' SES from the brands they follow. As you just seen, the results are promising on the aggregated level, but need a bit more fine-tuning for more precise individual estimates. Once we are more confident with the estimates, researchers could then combine these SES estimates with digital trace data on behaviors, communication patterns, and the social interactions to study inequality, health, and political engagement, among many other topics. For instance, one could link our measure of SES, which captures cultural and economic capital, to indicators of social capital inferred from social relations and interactions and Twitter, and explore how the different forms of capital combine to contribute to socioeconomic inequality. Actually, my own interest is we can now study the effect of social networks on inequality as discussed by DiMaggio and Garrett with this new data in a different context and on a significantly larger scale. Another thing to note is we use Twitter due to its popularity and the convenient API, but the principle of our method can be applied to many other online platforms. So we welcome any future explorations and collaborations. Thank you.